things have been evolving during the summer, so I this week changed the presentation to be more practical. What has been happening and what basically everybody who's owning a Salesforce org needs to be doing. Because Salesforce is also changing now how certain things in the orgs work. And actually that change starts today. So this is a very timely day to be talking about some of these things. But let's look at the basics first. I'm sure that most of you have heard or have even created connected apps. But what is a connected app? It's actually very important to understand the change, both the attacks and also the changes that Salesforce is now making. So a connected app is an inbound integration. It means that somebody is connecting into Salesforce from some other system or from a mobile phone or from a Chrome browser or from a desktop application. It doesn't mean that the data is always moving in. It might be that the data is going out, or it might be going both ways. This is about the inbound, outbound means like where is the initiation of the connection starting from. And in this case, it starts from somewhere else than within your Salesforce org. And that's a connected app. It's using OAuth, which is a authorization standard, and these days the internet runs on OAuth. It's basically used in every interconnection. When you go to your online bank or something, it's doing these sort of things. Something that is still quite important and maybe not very clear to everybody, it wasn't clear to me in the beginning of my Salesforce journey, is that connected apps are actually global. Which means that if you create a connected app in your org, it can be used to log into some other org. Of course, it still requires that somebody needs to authorize it to connect to that org. But connected apps are global. And it's quite important to understand this attack so that you don't just look at the connected apps that have been created in your org, because all the millions of connected apps out there can potentially connect to your org, as long as somebody authorizes them. And then there's one more term that Salesforce is also now using in some of this communication. This happened actually last year in Dreamforce. Salesforce launched ECA, which is Extended Client Application, which is essentially Connected App version 2. It has better security characteristics. The defaults are better. For instance, those tokens by default they expire, while connected app refresh tokens are forever tokens by default. But I think the most significant difference is that they are you can put them in a GitHub repository much easier. You can install them into orgs. You need to deploy them. They're not global. These sort of things. So it's more aligned with the CI/CD thinking, and I think that's the main reason why ECA exists. But there are also security benefits. So you've been reading the news. There has been a lot of big names out there getting breached, sending breach notifications that we have lost some customer data. And in many of these cases, it has been identified that they are related to Salesforce. All of these, they say that it's some third-party customer support system or something like that. But in many of the cases, the journalists have pinpointed that, okay, somebody said that, yes, it is Salesforce. So there has been a lot of news coverage about these breaches, and many of these are really relevant for Salesforce. And these cases are part of this breach series of breaches where the attackers are using data loader to to connect into an org and then to export the data outside the org. And what they do with the data is that once they have the data, they can extort the company for money, that unless you give us money, we will publish this information. And that's basically it. It's an extortion scheme. It's like a ransomware attack, but at least there's no indication that in any of these cases they would have deleted the data. They are just extorting that we will make this public. And of course, like nobody wants their customer records to be public. So it's an extortion scheme. And how is data loader related to this is that the attackers are essentially luring a user of a Salesforce org into authorizing the attacker's data loader to connect to the org. And how this works is the data loader, I'm sure that actually very many of you have used data loader and maybe are still using data loader today. It's a relatively old command line, not command line, but desktop tool available for Windows and Mac. There is also a command line version. Command line version doesn't suffer from these issues because the issue is related to the fact that there is this OAuth alternative, how you can authorize into an org with OAuth. The other alternative is username password. And now the OAuth is the problem here, because the OAuth in data loader is a flow, OAuth flow. OAuth has multiple flows. Some of them are more secure than others. Some of them are designed for a particular purpose, while some of them are designed for some other purpose. The device flow is intended for IoT devices. So when you connect data loader into an org, it will tell you that, hey, now you need to go to that org and you need to open this link and then you need to type in these 8 numbers there. Okay, then you get access to your org, and then you can export all the data, or you can insert data, or you can modify data. You can do all kinds of things with data loader, as you know. The problem is that this flow is authorized with this page. This is when you go to your org and you go to setup/connect and you type in those 8 numbers that data loader is showing you, then that data loader gets access to your org. Here you can see the first change that Salesforce did. Roughly 2 weeks ago, this popped up in this screen, this security alert. That didn't used to be there. So that's one change. But the thing is really how this works in an attack. And this is like very, very important to understand how the attack works, because this is not super simple. Well, the attack itself is simple, but why it works like this is the more difficult thing. So essentially, the attackers, they call the victim. A user of a Salesforce org, they call that person. And these attackers from the Scattered Spider and ShinyHunter gangs, they tend to be like younger people, like teenagers or in their 20s. At least that's the general perception. And they are from the UK and the US. So they have excellent language skills in English language. They're very convincing over the phone. So they call the person, and typically this would be a call to customer support, because the customer support phone number is very well known, of course, and people in customer support tend to have access to Salesforce, and they tend to have access to some data of all the customers, because they need to be able to handle their support cases. So the attacker they can call anybody in the org, but let's say that they call somebody from support. So they call a support agent. The support agent might be like an outsourced support agent, might be working in tier 1 support in a completely different country, not really working for the company. They call and say that, hey, I'm calling from the company IT. And we're starting to use a new ticketing system. And in order for you to use it, you need to do a very simple thing in Salesforce. Okay, what do I need to do? Well, you have Salesforce open in your desktop. Go to Setups and Connect, and you can see a box, this box, asking for 8 numbers. And in that box, type in 1, 2, 3, 4, 5, 6, 8, or whatever the code that the data loader gave the attacker. And then when the victim types in the number and clicks connect, the attacker tells over the phone, yes, everything seems to be fine now. You can now use the new ticketing system. Fantastic. Good day. And that's it. And now the attacker not only got access to the org, but they already have a tool that they can use to export all the data with a couple of clicks. So relatively easy. So why is this device flow now something that needs to be talked about, and why is it like now changing in a way that Salesforce is removing it from the data loader? We need to remember that OAuth is about authorization, not authentication. I'm a security person. I've worked in security for a very long time. To me, these two things are different, while they're quite often used interchangeably. But the authentication is when you go to Salesforce and you type in your username and password and then MFA, and then you're inside Salesforce. Authorization is when you allow a connected app to connect into that Salesforce. So if you first logged into Salesforce and then you do this. So authorization doesn't, in this case, require typing in username and password because the user is already logged into Salesforce. They are there all day, every day. This flow, this device flow, this is something that if you go to a hotel, there is a TV there, and you want to watch Netflix from your phone on that TV. This is the flow that you use. You go to Netflix, it will show you the 8 numbers. You go to that smart TV, open Netflix app, type in those 8 numbers there, and voila, you can watch Netflix from your Netflix account on the hotel TV. And then after you've done that, you can disconnect. So it's a great flow for Netflix. There is also another problem, and that is that this flow is one of those OAuth flows that doesn't actually require a consumer secret. So OAuth has 2 things. It has a username, which is Salesforce calls it consumer key. The OAuth standard calls it client ID. So Salesforce has a different term, but it's consumer key. And then there is the password, which is consumer secret. And many of the flows require the application to know both. This flow only requires to know the client ID, the consumer key, which is public information. Anybody can see what it is if they can install the application into their own org. And so this essentially makes it easier to use in a spoof attack than some of the other flows. But what is the most dangerous thing here is that the victim, because this is a very strange flow in a way for authorizing connected apps into your org, they might not think that anything wrong is going on. And that's why the call is kind of convincing, because the user is in their trusted Salesforce. They go to a page inside their trusted Salesforce. They don't go into some sort of phishing site, or like the URL is really your org's URL. And there is no password, there's no MFA. The attacker doesn't ask for a password. Even though in some of these cases, at least Google Threat Intelligence reports that in some of these attacks, they have actually done that they have asked, what is your Salesforce password? And the user has given them that over the phone. But in this sort of data loader attack, the user never gives out the password, and that's then probably something that has been taught them in security awareness training, is never to give out the password, never give out the MFA. But this flow is probably not part of the training. And this flow is also enabled by default. You can disable, for instance, username password OAuth flow in Salesforce, and I would recommend you to do that if you're not using that anywhere. But this flow, at least I haven't found a place where you can disable this flow. So what is Salesforce doing now to address these challenges? Is, first of all, normal users can no longer start the use of a completely new connected app. So essentially, they can only use connected apps that you can see when you go to manage connected apps in setup. So the admin needs to either create the connected app, or then they have to go to the OAuth usage or connected apps OAuth usage page to click install on those apps, and hence those apps, the configuration is created into the connected apps page. They can only use those apps. There is going to be this approve uninstalled connected apps permission, a system permission added, which will, as the name says, allow to use connected apps that are not in the page. So basically, that privilege gives you, that permission gives you the old experience if you have that permission. As far as I know, that permission is going to be part of the system administrator profile, probably not anything else. So, but you can give it to any permission set or profile if you want to. I wouldn't recommend that though. And one important thing also to understand is that old applications, so if somebody already has a refresh token, so somebody has already used an application, until that refresh token somehow needs to be renewed, the connection will still work. So like if somebody has already been using some application, that application will continue to work as earlier. But if a new user wants to use that application, they're not going to get a refresh token before that application is installed. And the change also includes this data loader thing. There is going to be a new version of data loader that has the web server flow instead of this device flow, and the device flow in the data loader, the old version, will stop working. And the username password flow will continue to work. So you don't have to update data loader in order to use data loader, but you need to use the username password flow. I would recommend moving to the new data loader and using the web server flow. The username password flow is not without its problems either, because your username and password will be there in the application. This change is happening basically starting today. So I don't know exactly when, which time zone, but today at some point on the 28th, new orgs, be they new production orgs, development orgs, or if you create a new sandbox or refresh a sandbox, they will then have these changes built in. And then starting 2nd of September, on the call where Salesforce explained these things, they said that, at least I got the impression that there is a roughly 2-week window when they're rolling it out. So like starting 2nd, for 2 weeks, this will be rolled out to all the orgs. So these changes will be happening in your orgs as well, starting next week, even if you don't refresh a sandbox today. Salesforce has a connected apps security feature called API access control. It has been there for maybe a couple of years. I don't remember when it was added. Hasn't been there forever, but it has been there for a while. If you go to Salesforce setup on a vanilla org, and you try to find API access control, it's not there. You need to reach out to Salesforce support and ask it to be essentially kind of installed into your org, so that the menu will be visible in the setup, and then you can turn it on. So I would say that that's a more hardcore version of what Salesforce is now rolling out to every org. So there are some key differences between this new way of doing connected apps with the uninstalled apps privilege, which is going to be the default from now on. So essentially, with that mode, if a connected app is installed, then everybody can use that connected app, including the attackers, because of course the attacker can also connect like Salesforce for iOS into the org and read the data from that, take screenshots. I don't know, maybe that's not a very practical attack, but anyhow, so everybody can use those apps that are installed. The API access control is different because there, with profiles and permission sets, you can define exactly who can use which connected app, and you kind of have to do it. So it means that the API access control is more work to deploy, but also continuously you need to manage. So there is more admin work with that approach than with the new default and of course with the old default. But I would say that the API access control is, of course, because of this granularity, it's a more secure option. So you should consider that. Look at that. Like, is it possible to deploy in your org? The thing, though, is that while I was prepared to talk about everything so far today, the world was also rocked again 2 days ago. So this is an attack that hasn't been talked so much yet, but this is something that has been happening in other ecosystems, not only in Salesforce, but this happened now in Salesforce. And unfortunately, these changes that are now rolling out and the API access control don't really protect against this threat. So essentially here, what happened was that Drift, which is a fairly well-known AI application in the ecosystem, somebody stole their OAuth tokens. I don't know how, but somebody got access to all of their OAuth tokens. And apparently this happened around 8th of August. So now, last weekend, there was a vulnerability disclosure from Drift saying that they have revoked all the tokens, and I even posted on LinkedIn that I wonder what happened, and maybe you should look at your Drift, what has it been doing. And now 2 days ago, there was a report again from Google Threat Intelligence saying that the reason why the tokens were revoked by Salesforce was that somebody had used those tokens and essentially accessed all of those orgs and exported data. So this is what Google says. Organizations using Drift integrated with Salesforce should consider their Salesforce data compromised and are urged to take immediate remediation steps. So pretty chilling description. The interesting thing from a security geek perspective in this attack is that the Google clearly states that the attacker wasn't only after the accounts and the opportunities and the cases. They were actually looking at Salesforce data and trying to find secrets. And by secrets, I don't mean some sort of secret blueprints or something like that, but like API keys and all kinds of other passwords, those kind of secrets that allow you to connect to some other service. And this is quite interesting from the perspective that maybe Salesforce, there are these named credentials. But before there were named credentials, it was quite common practice that basically these integration secrets were all over the place in various different types of objects or in Apex code or something like that. So clearly they were looking for those. They were Google named specifically that they were using, like they were looking for instance, AWS secrets. So in the security world, this is called lateral movement. So the attacker gets access to one system, and then they, from there, find a way to get access to other systems, and then to other systems and all that. So they move from these systems to other systems. There's a link. You can read the report. It's a very, very well written report. And I would highlight that here there has been an admin, because this is not a tool that I think that normal user would connect into Salesforce. There has been an admin somewhere who has integrated with this tool. So API access control, completely okay with this, and these new changes, completely okay with this, and this is not using the device flow. So these changes won't really protect against this attack. All right. So in addition to the changes that are now happening starting 2nd of September, you should be doing some other things, or maybe you have already done these things. But if you haven't, then here is a list of things that you should be doing. Also, some of these things are also related to the drift type of an attack scenario, because as said, the changes are not going to make a big difference to that. So one is that you should review your connected apps. While at it, maybe review all the other integrations as well. But connected apps specifically should be reviewed, because now the changes are of course going to affect how the connected apps work. So you need to make sure that you install the apps that you still want to use. But I would also recommend to block every app that you're not going to be using, because they're all part of attack surface, and you don't want to have extra attack surface. So block every application that you don't need. And if the org is old and there are lots of connected apps there, it might be a chore to understand what these even are. Then, if you're using a VPN, so that basically all your users are coming from the same IP address or IP addresses, I would recommend looking at locking down the IP addresses from where apps can be used and logins can happen. But this is not like, especially in smaller companies, this is maybe not that practical advice, because people are coming from whatever IP address they are at. Then you should change the the refresh token expiration date so that the tokens are not forever tokens. But you shouldn't change this for this sort of core integration between your ERP and CRM, for instance, because then what happens when that expires, that will stop working. So either you need to have a very good rotation thing where you always remember to rotate all the secrets in time, or then you need to have a very long expiration. Also, you should review the session settings in setup because the defaults are not the best. There are some things there. For instance, you can lock down the connection to the IP address where it started from, so that when the token gets stolen and it moved to another computer, to another IP, it won't work anymore. Things like this. Access permissions, and this is, I'll spend some time talking about this in the next slide, but access permissions are really, really important in all of these cases. And I would say that when you read through the reporting of the recent breaches, there has been surprisingly little sensitivity in the data that has leaked. Well, in some cases more, but sometimes less. So clearly some of these organizations had very good access controls in place. So the account that the hackers got into didn't see all the data, which is good, and which is what needs to be done. So it's not enough to try to prevent the attacker from getting in. You also need to detect when they got in, but then you also need to make sure that the damage is as limited as possible. So you need to be sort of prepared that if a breach happens, then at least like it's as low damage as feasible. And you need to start observing your connected apps if you're not doing it today, because in these cases, for instance, when the attacker uses data loader to download data from the org, the IP address of the data loader is the IP address of the attacker. And for instance, in this case also, the attacker's IP addresses based on the Google report were Tor IP addresses. So I would guess that none of your normal Salesforce users are coming from Tor. And also like the countries and locations and the time of day and all of that is probably kind of predictable. So you need to be looking at that, and also the volumes and the kinds of data that is being accessed is quite different when the attacker is doing these things looking for secrets.
What is Tor?
It's the onion router, which doesn't probably explain a lot, but it's this anonymization network, where essentially, this is a bad explanation, but essentially the connection bounces around in the network and then it gets out in a random place, and then you don't know which one of the connections going in was the one that was going out.
So like Tor throws and that thing goes, but then he gets it back.
Yeah, but it's like somebody observing the system doesn't really know like whose data is this like. So it sort of hides you in plain sight. You know. Yeah, well, dark web. Yes, that. Yeah, good. That's the term that the media uses. Dark web. That's the onion router. And then the last, but definitely not least, educating users is not perfect. It never works perfectly. But if you can reduce, let's say, if you, by teaching the users about these attacks, you can maybe reduce the probability of the attack actually being successful by 66%. It can make a world of difference. So even if it's not 100%, it's still very effective. So you should make sure that somebody in your organization, maybe the security team or somebody, like when they educate security awareness training, they also talk about this consent phishing is what at least in the Microsoft ecosystem this attack is called. That it may not be that somebody's phishing for your password or trying to get you into going into a fake website and typing in your password, but instead somebody is trying to lure you into authorizing their application into Salesforce or some other system. So this is very important, and including like at least until device flow is completely gone, also including the device flow into the training, so that people recognize that this is probably not a good thing. I'm not going to type in the numbers. So last topic about this, the least privilege. So why is least privilege so important here? So in these cases, if you read through this, well, I'm sort of, the public information is kind of scarce, but if you read through those and read between the lines, I wouldn't say that in any of these cases the attackers have gained access to an admin account, at least based on the description of the kind of data that has been exfiltrated and the kind of damage that has been done. But would the attacker ever get access to an admin account? They could do bad things. They could disable backups, then start deleting data. They could even use Shield or Crypto API to encrypt data in the org and then throw the key away or ask you for money for that key. They could kick out every legit admin and be the only admin in that account. They could create all kinds of different backdoors. There are multiple ways how they could create, like with Apex code or other things. They would create different types of ways of retaining access to the system, even if the account that they initially got access to is closed. And they could read secrets and do this lateral movement thing. They could access named credentials and connect to the other systems that Salesforce has access to. So it's critical that you lock down the admin access and minimize the amount of admins. Of course, you don't want to minimize it to a 1. What if that person is on an airplane and something bad happens? But minimize that amount of admins that you have, and also minimize the permissions that every other user has, so that they can do their job, but they can't really do much else, so that the damage is as minimal as possible in this case. And remember that it's not just about permissions. It's about the licenses, because if somebody has a weaker license, they can't, like, there can't be even a misconfiguration where you can give them accidentally too much access. It's about permissions for sure, access to objects. But then also, do they have to have access to all the records in the objects? Usually no, so sharing. And this is quite important. This is where it all starts from. And this is, I'm sure that, like, for every Salesforce admin, this is the bread and butter that you do every day. And yeah, and then if you need help with doing this thing, reviewing the connected apps, observing what the connected apps do, with the permissions, with the sharing, all of this stuff, Valo has a solution. In App Exchange, we have a free 30-day trial for doing this thing. And yeah, in a way, it was purpose-built for what has been happening this summer, even though we don't have a crystal ball. But in that sense, it is really designed for these kind of risks.